Hello everyone. Good morning. Welcome to an informative webinar by Royal Cyber. I'll be your host and one of the speakers for today's webinar. Some of the ground rules for smooth experience before we begin. We will be going through this webinar as per the agenda, and in between, if you have any questions, feel free to post us on the chat window. There will be a dedicated slot for Q&A. You can also post your questions at any point of time, emailing to this email address info@royalcyber.com even after this webinar. There will be an webinar survey form will be circulated at the end of this webinar. Please feel free to fill in and revert back to us. In case if you have any trouble in hearing the audio or looking at the screen, please feel free to text to us on the chat window. All right. So here we go. So today's topic is migrating a mainframe workload to cloud. This is joint webinar. We Royal Cyber jointly presenting along with our partner Heirloom Computing. Yes. Today we have Gary with us from Heirloom Computing, and he is going to present us the Heirloom's migration solution, which migrate workloads from mainframe to cloud in an automated way. And myself, Vijayalakshmi, manages a mainframe practice at Royal Cyber and helps our customer for modernization and integration and migration solutions. Here we look at the quick agenda of the day. We'll have quick introduction about Royal Cyber and our practices and our in-house solutions. And of course, today's topic on migration, what is the need and the benefit and what solution we're going to discuss, and of course the live demo which automatically migrates mainframe application to cloud, and followed by Q&A. Royal Cyber is a fast growing IT consulting and digital transformation company specializing in IT services and solutions. We have 2 decades of experience. We have 1,800 consultants across the globe. We headquarters with Naperville, Illinois, USA, and we have our global presence: UK, Canada, Australia, New Zealand, and Middle East. We do have multiple offshore development centers in India. Most of our consultants are certified with various technologies. We have a strategic partnership with a lot of technology company like IBM, Microsoft, Amazon, Google, Heirlooms, Broadcom, and others, which eventually helps our customer for digital transformation journey. About our practice, we provide reliable and high performance solution for our customers. Within mainframe practice, we offer mainframe infrastructure management, wherein ZVM, ZLinux, ZOS, and other ISP product install and upgrades. Application services, wherein application support and enhancements. Mainframe modernization, where we do front-end integrations, product installs, configure, and integrations with middleware, and also DevOps tooling integrations. Managed services for application and infrastructure support. So these are our some of mainframe customers to whom we work with infrastructure support and application, as well as the modernization related engagements. Here is our in-house assets or solutions. From our practice, we have some automated solutions like migration tool, migrates, microfocus, Cobalt to PeopleSoft, and SEM migrations from Endeavor to RTC, or maybe Endeavor to GitHub with the extract, transform, load approach. We do have Urban Code integration with Endeavor. CA Endeavor and IBM Urban Code does not have any plugins to support for integration. We have Royal Cyber customized application which integrates this and allows us automated deployment through UCD. And we do have a middleware monitoring tool called Monitor Pro, which monitors MQ, IAB, and data power, which runs on Z system with an web-based interface. And we have some custom code review tools, and also custom code review does a domain specific reviews, and Z DevOps solutioning for DevOps orchestration, and web-based application for password reset. Coming back to today's topic, migrating a mainframe workload to cloud. So migration is quite common, but migrating a mainframe workload is a bit challenge. It's not so easy to migrate a mainframe workload to other distributed or modernized environment. But still, why do we need migration? So there are some major factors or driving forces which uh, which acts as the driving forces for migration, or cost, agility, and inadequate interface or development environment, and the skill gap. Mainframe cost is huge in terms of on hardware, MIPS consumption, as well as the software licensing cost, ISV product licensing cost, and the resources are at higher cost. So while migrating, we can able to reduce the MIPS consumption and the software licensing cost. Agility is the next important aspects, wherein legacy system lagging with an agile, and customers are facing difficulties in deploying new functions and enhancement in short span of time. So agility can able to reduce time to market. Inadequate code analysis and legacy interfaces leads to more time for code analysis and the development. And skill gap, mainframe applications were written long back, and mainframe experts are almost getting retired, and getting right expertise is bit challenge. So migrating will help you to fill in the skill gap with the cutting edge technologies. Some of the goals of migration: while migrate, we can able to easily maintain an application. We can get the similar performance as similar to that Z server, or even a better than that. And data integrity and security, it reduces your cost, infrastructure and software cost. And it also supports for your agility, continuous stability, availability, and of course, it reduces your talent risk. So now, coming back to migration approach, there are various approaches we have for migration, refactoring or rehosting, platforming kind of stuff. But the which approach we are going to adopt depends on the type of the workload, application sizing, and the destination architecture. And today's topic is all about, we are going to look at in detailed uh, view of Heirloom's migration solution. It has an automated migration from a mainframe workload to cloud. With this, I'll hand over a call to Gary from Heirlooms for a detailed automated migration solution. And over to you, Gary. Thank you.
That was great. Thank you, Vijaya. So, when discussing modernization, the industry frequently uses terms such as replatform, refactor, retire, and replace to describe the different approaches. And we do too, but beyond the constraints of those terms, Heirloom is really about reinventing the mainframe using open, modern technology stacks. And the most common pattern with our clients is one that sees them migrate workloads quickly so that they can reinvest the cost savings to modernize and transform their applications on an agile platform. At a strategic level, the data center is no longer considered to be a differentiator, and migration of mainframe workloads to the cloud changes everything. That shift to the cloud and cloud-native platforms is the foundation of digital transformation imperatives that enables enterprises to attack the increasing technical debt that impacts their agility today. With an Heirloom migration, OpEx costs are reduced by at least 65%, with ROIs that are frequently within 12 months. Elastic infrastructure means the business can dynamically adjust throughput and cost based on demand. Load balancing and failover of workloads across multiple geolocations is now easily provisioned, providing unmatched global availability. Open modern technology stacks are developed by engineering communities that continually push the boundaries of what's possible. And perhaps your most important asset, your data, is migrated and securely stored in managed relational databases, enabling access from any system and from anywhere. Changing your ecosystem enables you to move beyond limited tools and application frameworks by leveraging a wide array of open software to accelerate your modernization journey. And that ecosystem shift also gives you the opportunity to replenish and revitalize your skills pool by drawing upon the new talent immersed in the latest technologies and best practices. Simply put, Heirloom is a proven software platform that provides the fastest, lowest risk approach to migrating mainframe workloads unchanged as cloud-native applications on any cloud. Heirloom simultaneously produces replatforming and refactoring outcomes, putting you in complete control of your modernization journey. Capable of migrating millions of lines of code and data in minutes, Heirloom delivers the best ROI of any solution in the market. And a cloud-native end state on an agile technology stack means the business can accelerate the delivery of new services. The original application source and the associated SME knowledge is retained, providing unmatched flexibility for post-migration modernization with teams composed of mixed skills. Heirloom creates cloud-agnostic applications that insulate the business from cloud vendor platform lock-in. Application execution on a modern, agile ecosystem greatly expands the pool of available skill sets, giving you a way to modernize and upskill your development teams. And if language transformation is part of your modernization strategy, you can do that at a pace that is optimal for you, and that greatly reduces the associated risks and costs. Hybrid models are also supported, which means that you can integrate migrated applications with your downstream mainframe workloads and processes, or enable the migrated applications to directly access datasets resident on the mainframe. From a technical perspective, you can think of Heirloom as a complete mainframe platform implemented on the JVM. It has native support for all the primary mainframe technologies, so languages such as COBOL, PL1 and JCL, transaction processors such as CICS and IMS, and a complete JES JCL system for batch processing, so you can run your batch applications without any changes. And just like the mainframe, Heirloom uses compilers to build and deploy applications, which means that the code migration is very fast and 100% accurate. Heirloom migrates mainframe applications using an orchestrated process to automate and accelerate project delivery. The process starts with Probe, which is our analysis tool, and that's used for portfolio assessment before the migration project starts, and for inventory analysis and collection during the migration project itself. The Heirloom toolset migrates code and data and creates cloud-agnostic applications that can be deployed to any cloud. HData is our mainframe resident data access layer, and that provides real-time read-write access to mainframe datasets from applications executing in the cloud. And that's a powerful option for hybrid applications. Now, without the right solution, mainframe migration can be very challenging. And unfortunately, there are a lot of solutions in the market that have overpromised and underdelivered. And so we take great pride in delivering successful projects for referenceable customers. And I would now like to step you through a couple of recent examples. Venerable was formed as the result of the divestiture of Voya Financial's insurance business. And this was a really very complicated workload. It made extensive use of pointer arithmetic, passing around large memory areas via transient storage queues, as well as long-running workflows dependent on multiple background transactions. Nonetheless, we delivered that project 8 months ahead of schedule, and the system was deployed to the AWS cloud. As a result, Venerable has realized cost savings of over 65%, which for them means savings of over $1 million every month. A great example of the speed and agility Heirloom can deliver is a project we completed for AREC in Finland. All of Finland's pension companies use AREC's pension services. And what we did was to migrate AREC's pension calculation engine, which was 22 million lines of code, mostly COBOL, but some PL1 and assembler as well. And we refactored it as a Java Spring Boot service deployed to a Kubernetes cluster on the Google Cloud. We had that entire system up and running and successfully processing test messages in just 3 months, which for a workload of this size is impressive by any measure. This is one of our favorite projects, not just because of the speed and delivery that we achieved for a very large application, but because it is also a really great example of how we took a vertically constrained monolithic system and produced an infinitely scalable service on the cloud. Not only was the production system 152% faster than the mainframe, but the cost reduction for AREC was a staggering 85%. Okay, with the overview complete, we're now going to hand over to Ian to take us through some live demonstrations so you can see what Heirloom can do.
This demo uses a 3270 Kix application on our Australian mainframe. For reference, you can see that running here. It's our small accounting application. We're going to use Probe and the rest of our toolset to replatform this application from the mainframe to AWS Beanstalk here in the States. If you think about an application stack as a pyramid with dependencies building as you move down, that's how Probe treats an analysis. So we'll start at the top of the pyramid for assembling the assets for this application. In this case, it's the Kix transaction definitions on the mainframe. Just to complete that analogy, for batch applications, we'd start with the JCL as the top or the entry into the application. So Probe will assemble and analyze the assets, and then in this demo, invoke the rest of our tool set, our data migration tools and the compiler. We'll automatically migrate the COBOL code to the JVM and the vSAM data into a relational data store in Amazon RDS. This is Probe's main interface. I have it pre-configured to know how to connect to our mainframe, where to find files there, where to store files locally, and as I said, it's in automate everything mode. Obviously, all the steps you could see can be executed manually and repeatably. It's going to run quite quick, so I'll describe what's happening as it goes. While the demo is fast, I think it does demonstrate very well the automation that Probe can potentially provide and the potential to massively speed up application migration. So let's start the process. Probe will connect directly to the mainframe. It'll retrieve and analyze those Kix definitions and then look for dependencies. In this case, the programs invoked by the transactions. It'll find that we don't have that code locally, so it will reach back to the mainframe, download the source code for those programs automatically. It will then loop around again and again, reanalyzing each new set of assets it finds, and downloading other missing programs, missing copybooks, screen definitions, everything that makes up the application. The goal here is to collect the entire set of application assets up front, rather than discovering missing assets midway through a project. Now we can do this manually by asking an SME to provide those missing assets, of course, or as you can see here, we can attempt to find them automatically from the mainframe if we have access and we have the location specified. Once we have all the assets, Probe will then download all the file metadata. So layouts, primary keys, alternate indexes, everything we need to know to transform those files into a relational database. And this is where we can cut weeks and months of project time. Rather than gather that data for thousands of files manually, we can automatically collect that crucial information and then construct DevOps scripts that can automatically migrate those files whenever we want, repeatably. And that's what Probe is doing now. It's going to automatically migrate our vSAM file from the mainframe into a table in Amazon RDS. Now that gives us not only excellent scalability for that data, but also access for other applications via standard SQL views. Once the data is migrated, we turn to the application code itself. And again, we run build scripts that will invoke our compiler and replatform the application. So again, that's what's happening here. We're using Gradle scripts in this case to do that work. So this is a repeatable DevOps pipeline process. We can run this anywhere at any time. It's compiling, it's packaging the application, and then in this case, it's deploying it to Amazon Beanstalk. So it'll take a few moments to finish the deployment. So let's recap real quick. We started with the Kix application definitions on the mainframe. We used Probe to automatically analyze and assemble those assets, and then migrate both the code and the data to AWS. So this is nearly finished deploying. We'll give it one more moment. Here we go. So let's go take a look at Beanstalk. So we've delivered the WAR file to Beanstalk. It's going to take a moment for Beanstalk itself to deploy that WAR around the cluster. So we'll give this one more moment here. And that should refresh in a second. Then it should be good. Let's go take a look at this application. There we go. Okay, so let me just make sure I've got a data connection here. Yep. So out of the box, this is our application. We automatically create a browser-based version of the original mainframe one. It intentionally retains the look and behavior of the original 3270 application, and that makes moving for users incredibly seamless. You know, you're not just moving code and data here, you're bringing users along with you. But, you know, as we've said, this isn't just about automatically migrating an application. It is about agility. This ability to rapidly transform and to continue to refactor an application going forward. Heirloom's ability to automatically expose business rules as REST services allow us to drive the application from new frameworks, to exploit new targets like mobile, and entirely new paradigms like API integration. As a small example of that, I'm going to show you this exact same application, but with a modernized interface. So part of the script we executed to deploy it, deployed a small piece of JavaScript based on EXTJS framework. To be clear, this could have been React, it could have been Angular 2. We just chose to use EXTJS in this case. This is the exact same application running under the covers. There's no code changes. We're simply using the JavaScript to drive those REST services and then to display the returned JSON data in a new form. So rather than having pages of 3270 data that you PF8, PF7 backwards and forwards through, we have a nice sortable table. We can bring up that data in new and interesting ways and break it out. And then, of course, we can augment these existing business rules and add value. As an example of that, we've taken the address and we've hooked it up with Google Maps. So now we get a map view of the address, again, without changing any of the underlying code. So, because we provide the capability to refactor from either a COBOL or a Java perspective, it's incredibly easy to then go about the idea of strangling or breaking the monolith and turning these applications into macro or microservices using facade wizards within the IDE or indeed any industry standard technique or tool available to you. So I have an example of doing just that. We've taken a business rule from this application. It's actually 2 paragraphs that retrieve a customer's balance based on a customer ID. We've deployed that to AWS Lambda as a service, and then we've connected it to an Alexa skill. So I'll demonstrate that using their test framework rather than a real device so that you can see that in action. Open account demo. What is my balance?
Your account balance is $76,543.22.
So to be clear what's happening here, with no underlying code changes to the original application, we've taken a specific business rule within that application and we've connected it to a digital channel, in this case voice. Okay, that's what I have for the demos. Thank you.